use transistor and build amplifier out of it. This class is the moving to transistor based amplifier to operational amplifier. Very important topic for you to learn. Practically also you will be able to do. There are a lot of operational amplifier circuits available. At least the basics ones you will be able to build easily and verify it's working. Okay. So unlike transistor based amplifiers, the analog components and building amplifiers out of it, operational amplifier based circuits will be easy to build and definitely it will work. Okay. Whereas the other circuits there is a small uncertainty. Sometimes it will work. You need some expertise to build that circuit for that. This even 8th standard, 9th standard student who can follow set of instructions, understand some basic things will be able to do. So definitely you can do it. So on the left side, what you have is operational amplifier symbol. Two lines. Operational amplifier and the acronym short form of that is op amps. Normally people refer to it as op amps. It's actually operational amplifier. The symbol says it has two inputs, V1 and V2. One is called, of course, one is connected to a negative sign and the other one is a positive sign. One which is connected to negative sign is called inverting input. That means whatever input you give, the negation of that will come as output. That's why it is inverting input. Non-inverting input is the one which is in the bottom, V2. That means if you give a positive voltage, positive output will come. If you give negative voltage, negative output will come. If it is an amplifier, naturally there is something called gain. Input multiplied by gain will be the output. So that's the max behind it. So you have two inputs, and the operational amplifier amplifies the difference between V1 and V2. Difference between V1 and V2. V1 is a voltage, V2 is another voltage. The difference between V1 and V2 gets amplified and available in the output, V out. Of course, there is a ground, a line representing ground. That's the symbol. And on the right hand side, you have the VI characteristics. Input output characteristics. The x-axis is the input. The input is differential voltage. What is meant by differential voltage? Difference between the two inputs, V2 minus V1. That's the input. And V out is plotted in the y-axis. Okay. When V1 equal to V2, the difference is 0 and output is 0 because anything multiplied gain. Normally amplification means what? You have input, you have an amplifier, it will have a gain. Input into gain will be the output. That's the math. So here differential input is 0, the output is 0 naturally. And if the differential input is positive, on the right hand side of the vertical line, you will see you get a negative output on the output side. Okay, and that reaches the so-called saturation, the horizontal line on the right hand side. You see a horizontal line. That line reaches, that's called saturation point. That means the amplifier will no more able to give output than that voltage. For instance, you can visualize this voltage as VCC in your transistor based amplifier. Suppose I give transistor based amplifier VCC as 12 volts. At any point of time, amplifier cannot give output more than 12 volts because all it can supply is 12 volts. Anything less than that is possible, but anything greater than 12 volt is not possible. So the moment output reaches 12 volt, and even if input increases, gain, you increase the gain, output will not increase because that is the maximum voltage that the amplifier will be able to give. This state we call it as saturation. It has saturated its maximum capacity. It has reached its maximum capacity. No more increase is possible. It's saturation. So on the negative side, there is a saturation. Similarly, on the positive side, when the difference is negative, you have positive voltage output coming out. That's there in the left side of the vertical line, and that also reaches a maximum, that is saturation on the positive side. So you have input-output characteristics for the operational amplifier. For operational amplifier working, you need to give a positive VCC and a negative VCC. Whereas in transistor-based amplifier, we have given only VCC, positive VCC, right? VCC means what? Source voltage is for the operation of the circuit is only VCC, that means 9 volts, 12 volts, whatever it is. In operation amplifier, you have to give two inputs. There it was one input. Here two inputs. Another one, you have to give one positive power supply, one negative power supply. 12 volts means plus 12 volt, minus 2 volt. Both you should have. There it is plus 12 volt and ground in the normal amplifier. Okay. What are the very important characteristics of op-amp that makes very attractive to us? It has very high input impedance. Very high input impedance. What is meant by impedance? Any idea? Resistance. Impedance means resistance. I have connected the op-amp to a voltage source or a transducer which gives electrical signal. If it has very high input impedance, means it has lot of resistance for the current to flow. For the current to flow from sensor to operational amplifier. That means it will not draw more current from the sensor. Okay? It's a very important characteristic. It should not take more current from the source. Okay. What if draws more current from the sensor?
Loading effect.
Huh?
Loading.
Yeah, loading effect will be there. If the loading is too high, sometimes you take a thermocouple, you maybe connect it to a device, the output of the thermocouple connected to a device which has less input impedance. Already there is a small 0.3, 0.4 millivolt coming from the thermocouple. Yeah. Very small voltage and small current proportional to that. You connect that to a circuit which has less input impedance, that it will draw current. The moment it draws current, there won't be any current for thermocouple to provide and make the circuit continuously working. It is something like that. In the fluid pipes and flow-through pipes visualization that we discussed yesterday, last class, if already there is a thin tube of water that is there in the tube. Already the tube is thin and the water is coming there is thin. If somebody sucking it from the straw, if somebody already removes it and no more water is available in the source side, then it will be like an empty glass. You put a straw and suck. There is nothing will come. Only air will come. The liquid will not come. Juice will not come. Okay. So same thing will happen in electrical circuit when feeble signal like transducers giving outputs. If you connect that to a low impedance device, the low impedance device means what? I don't have any big resistance for the current to flow. Whatever is the current that will flow to my circuit, and my circuit will lead away all those current. Okay. If the sensor should have sufficient current to keep on producing, keep on sending the current to the amplifier, so that the amplifier does the function of amplification continuously. Already the signal is weak. The moment you connect, what will happen is that the signal will die automatically. You can see this. Those who want to test, take one normal amplifier, just connect it to a thermocouple, and you will be able to see if input impedance is less. You give input signal, take the output signal, connect it to CRO or connect it to very good multimeter and see the output. Sometimes output will be zero. Output will be zero. The thermocouple will be working, circuit will be working, everything is fine. That's because the small signal that's coming out of the sensor is already eaten away by the amplifier. So, important characteristics of an amplifier, along with three characteristics we have already discussed to qualify it as an amplifier: faithfulness, external power supply, amplification of the power level. Apart from this, it also should have very high input impedance. It is a desirable characteristic, not essential. Even if it is not having high input impedance, we call it as an amplifier. But desirable characteristics is high input impedance. High input impedance means I will not disturb the signal that is coming in, but still I understand this is the signal. Oh, 0.2 volt is coming, 0.1 ampere current is coming. I understand that an amplifier and give the corresponding signal from the other side. Okay. So high input impedance is important characteristics, and op-amps has very high input impedance in the order of few megavolts. And another important characteristics is whatever the current flowing to the amplifier, it should resist. But amplifier is connected to some other device, maybe a data acquisition unit, maybe a display unit, maybe some other control unit, whatever it is. That device, for its own functioning, may need some amount of current. Sometimes it draws current. The amplifier should be able to provide any amount of current without shortage. It should be able to give. That means the amplifier should have very less output impedance. Input impedance should be high, output impedance should be less. Any amount of current it should be able to supply. These two characteristics are very important characteristics of an amplifier. Okay. It is desirable, but if it is not meeting, you will not disqualify it as an amplifier. Still you will use it, but it will be a bad amplifier. Okay, it is an amplifier. So that's an important characteristics, and op-amp has that characteristics. Output characteristics is only few ohms. Imagine meg ohm. Meg ohm means mega ohm. Mega ohm means how many? 10 power 6 ohms. So much input impedance. Almost signal is not disturbed at all. Whereas any amount of current you draw, you will be able to draw. It has infinite gain. That's another beautiful characteristic. If you take normal transistor based amplifier, there is a limitation for setting up the gain. Maybe gain of 5, gain of 10, maybe gain of 100, 1000. That's all. Then you have to go for stage 1, stage 2, stage 3, like that multi-stage amplification you may have to do if you want more gain. Whereas operational amplifiers are capable of having gain of up to few lakhs, 10 power 5. Whereas 100, a gain of roughly 100, and whereas 1 lakh, okay, a few lakhs it can go. That means 1 microvolt, 2 microvolt can be amplified to a volt or 10 volts, that way. From millivolts to few volts, it will be able to amplify in 1 volt, 1 IC, in 1 stage. And that's a very desirable characteristics in signal processing that we have, especially with sensor signals. They are all very mild signals, not having very strength, not 5 volt, 6 volt, 10 volt as coming from the output from most of the sensors. For example, EEG signal that you take from the skull or from behind the ear, the ENT specialists take Vera signal from here, EEG signal, electroencephalogram signals from here, or from muscles, EMG, electromyogram signals that we take from a body. Of course, we are not going to learn those things in detail, that's biomedical stimulation. They are all in microvolts. The highest signal you can get is few millivolts, 0.1 millivolt, 0.2 millivolts, something like that. Very small signal. If you want to amplify and do, you need a lot of gain, but also infinite bandwidth. What is infinite bandwidth? We already discussed bandwidth. Frequency? Not different. Frequency range. It's a frequency range. A range of frequency. It has very good frequency range. That means it is not biased towards frequency. Whether you give a very low frequency, as good as a DC signal, or you give a very high frequency like frequency of megahertz, gigahertz, and things like that. the operation amplifier will treat all of them almost equally. I very carefully use the term almost because it is true to a greater extent. It will equally treats, but there will be minor partiality. But for all practical purposes, we say it treats all the frequencies equally. Okay, that's a good look at it. All four are very important, and op-amp has all four. It is a man-made device. It is not like purposefully it is designed like this. We want high bandwidth, we want high gain, we want a high input impedance, we want low output impedance. These are all an ideal characteristics of an amplifier. They have designed with all this. What did they do? They took normal amplifier only, and then this amplifier only they have taken. They have abstracted this. What is meant by abstraction? You just look at that as a concept. You have a lot of components, a lot of circuits, but finally, what I do, I take two wires, connect this. So I need a place to connect it. Okay. There is one power supply that I have to connect, one ground and one power supply. And there is two ports. There is a port, two connections where I need to take output from. Okay. So I need a input port, output port, and power port. So this is input port, that's output port, and this is power port. VCC. Rest all is a component or components that goes inside. So what I do, I make very generic design. And whichever, for example, if the gain can be adjusted using RCC, or if the gain can be adjusted using RE or R1 or R2, I just provide the connection outside as a pin. Here you can connect R1, okay, and then you can connect for a specific application. You can choose your R1 value 1K, 2K, like that, or you can put a variable resistor and tune according to your requirement, like that. Except that all transistor, rest of the resistor, capacitor, all these blah blah components are same. I don't want to change at all. Gain can be adjusted with only one resistor. So give provision for the people to connect the resistor. Rest of the component you make in the form of one IC, integrated circuit, and put all of them together in the box, in a black box. That is what they have done. Put all of them in the black box. Give provision for input, give provision for output, give provision for connecting power supply, and put rest of them inside that track. That is actually called operational amplifier. You get one IC, integrated circuit. Okay, there is a huge development in integrated IC, integrated component technology. So people have found the cost of manufacturing, the cost of components after the manufacturing reduced drastically after this. Suppose if I am making an amplifier by buying transistor, few resistors, few capacitors, all of them soldering, and the board of course that is needed for that. All that, let us say if all of them comes to around 12 rupees, 13 rupees, on a manufacturing scale. If you make an IC, you will be able to make IC for 5 rupees. So the same function, drastic cost reduction, and there is no variability from piece to piece, because IC technology is so consistent that if you make the ICs, that will perform the same way for thousands of pieces. So operational amplifier gained a lot of momentum because of this, and then so we have provisions for input, output, and then power port. Inclined line store. This is input, output, and this is power. Rest of that are abstracted and put inside this IC, and hereafter we will have only IC pin number 1, 2, 3, 4, 5, 6. The IC manufacturer will tell pin number 1 and 5 is power supply or input, 2 and 3 is power supply, 7 and 8 maybe for connecting resistors. This is for output. He will describe where to connect what. So you should not question that, because he has designed the circuit like that. So hereafter the question that you should ask is, where should I connect input? You look for the data sheet. Oh, it is pin number 1 and 7. 1 and 7 you connect. 7, for example, I am not saying you have to look at the data sheet. of one typical IC will be 741. 741 is operational amplifier circuit. 741 data sheet you take, and they will tell this pin number is ground. This pin number with respect to ground is input. This pin number with respect to ground is output. These two pins are power supply. This is positive, this is negative. But then for each pin number they will tell you what is the function. There are some pins without some function also. That's because IC has some standard. Either you can make 4 pin IC, or you can make 8 pin IC, or you can make 16 pin IC or 10 pin IC like that. You cannot make 7 pin IC. If circuit needs only 7 pins, they will make it 8 pins, but 1 pin they will leave it free, unused. Unused pins also may be there. So hereafter you will have only ICs with each leg or each pin assigned to a certain function. We have explained this circuit of operational amplifier. Anyway, before going to that, there is a mechanical operational amplifier. We can just visualize so that you will be able to appreciate the working of operational amplifier in the electronics domain. There is a positive. This is a pneumatic circuit. This is a pneumatic circuit. The positive power supply means a high pressure air is coming. Negative power supply means what? A vacuum. Pressure below atmospheric pressure is there in the tank, so the negative supply will come. And whatever is there in the light green color, which is connected to a lever, that can be rotated like this. It's like a ball drum, it can be rotated like this. And when inverting input, non-inverting input, or the forces that we apply. Inverting input is upward, downward force. Non-inverting input is the upward force. If both the forces are equal, the lever will not move at all, no. When downward force is more than the upward force, there is a difference in the force supply. That proportional to the difference in force supply, it will be moved downward a little bit. When it is moved downward on the negative side, you will see that the positive power supply comes through that T joint and then goes to output. Goes to output. You keep on increasing the downward force, the output keep on increasing drastically. And in a short difference, you will find that no more output coming. That's the saturation. It has reached its saturation. Okay. And beyond that, if you increase the inverting downward force also, you will not see the proportional increase. Same amount of high pressure will be coming. It won't increase further. That is the saturation state. Same thing you can do by upward force. Upward force can be more than downward force. Then the whole setup will move in the clockwise direction. This low pressure will get connected and high pressure will be blocked. This will go through the pipe T joint and then go to the output. Actually, this is drawn by me, so I have made a small technical mistake. The concept was stolen from MIT side. One professor from MIT was explaining this to the student. So I have just grabbed the idea from that so that now we can use that in the classroom. But while reproducing, I made a mistake. The output port that is there, that should be a little more thicker. The one which is coming horizontal, that will be a little more thicker. But when I was drawing, I made almost same thickness. Actually, it has to be a little more thicker. Okay. The vertical line in the D is correct. The horizontal portion should be a little more thick. Now it is like this. It should be a little more thicker, so that the operation you can correctly visualize. It will be exactly same as electronics operation amplifier function. So this is operation amplifier. What is the operation amplifier working? You have two inputs. The difference in inputs is amplified and given as output. If you view positive difference, a negative output will come. If you view a negative difference, a positive output will come. And up to certain limit, there is a proportional increase in the output with respect to input, the difference in input. Beyond that, it reaches a saturation. Both on positive side and negative side, there is a saturation. That's what is the VA characteristic, not VA, input-output characteristics I have described in the very first slide. Same idea you can explain with pneumatic example. Okay. Now, electronic operation. Is it time? Okay. Okay, then we will stop here because next this is abstraction. Stop.